And we're back. Welcome back, everyone. I hope that you have checked in before. You do know that I'm Anton. We are doing this as a part of the Discover Robotics via STEM, a Erasmus Plus sponsor program. I am a part of FabLab Nordvest, and we do hope that what we do here will help some students and some teachers increase their knowledge about robotics and help them kind of use that to teach STEM better and teach STEM more, so that we can have kids who have the same skills as I do at a younger age, so they can get to a much higher level throughout their life and education. Today we're going to talk about Arduino coding. Last time we were talking about digital electronics shortly, and then moving into the Arduino IDE and Tinkercad. And today we're going to try and just cover some of the most simple principles of coding, because as we talked about the last time, what really makes the Arduino so amazing is that we can create code on our computers and upload it to it, and it will execute that functionality really, really well, which is quite unique for a product so cheap, with components that are also extremely cheap. So without further ado, let's get into some of the simple principles of how to code one of these. Again, just if you forgot, there are the digital pins, the analog pins, and the simple values or the simple functionalities on the Arduino. Just to mention, one of the more interesting things when we do get into the code is that the Arduino is actually able to read better than it is to write, or in this context is better at analyzing values that it receives in the analog pins, where it can receive a value between 0 and 1024, and when it's sent out values, it's between 0 and 2056. This is something to do with bit structures and stuff, but it's just a very interesting thing, and you might see these things popping up when we start to do functions or codes where we work with the analog signals and the digital signals. So just for those of you who might look at the numbers and think, why is that number the right number? It is just something that's programmed into the Arduino. Again, the programming language that we're talking about is the Arduino programming language. It is mainly based on C++, as we covered last time. There are also other options. There are options like mblocks, which a lot of the students here have been taught throughout this project. It is more Scratch-based, but does kind of, you can say, actually upload code that is in the Arduino, or probably even in the ones and zeros language, machine code, to the Arduino, but using the platform of Scratch as inspiration instead of writing C code. So there are many ways to define code. When I work with Arduino code, generally I think there's two categories or two ways of types of code, and knowing the difference between the two is really, really useful. I call these types component code and functionality code, and they're very different in nature. Component code is code that interacts with the pins, that interacts with components like the LED. It can be really, really complex codes for complex components, some of which you're not going to write, but you're going to borrow. But more importantly, it's just, we're not thinking in terms of algorithms, we're thinking in terms of getting the right signal from the type of component that we're holding, or sending the right type of signal to it. The most common ones are read and write, but there are many, many more. And when we work with the components, we have to think about whether or not we consider them to be digital or analog components. So do we need to add them to the analog pins, or do we need to add them to the digital pins? Digital values, again, we've talked about this earlier, is either a 0, a low, or 1, a high, or 5 volts, many other things you can use to characterize this, but it is kind of like this: yes, no, 0, 1, high, low, extreme, nothing. all this. But the components reflect this. So think of the push button like this. It has nothing in between being pushed down and not being pushed. There's no I'm pushed halfway, or I'm pushed 2/3 or 1/3. It doesn't exist with this component. This is a great example of a digital component, as we can see here. It is a, you can say in that regards, a sensor, and it is because it senses whether or not we are pressing or not pressing. It sends a 1 if we are, or 0 if we're not. Then we have components which can be kind of both. Think of an LED, for example. If we tell it to blink with maximum value and then turn off immediately after, we might consider it digital. But we can also make it dim up slowly and then kind of slowly go towards 0, and suddenly we're using it as an analog component. So my advice when working with component code is to always consider whether you're working with a digital component, an analog component, or a very complex component. That could be, let's say, a LCD screen. Luckily for us, beginners, intermediates, even to some extent experts, a lot of the codes have been written already. We are not as original as we sometimes think, and if we look and spend some time searching on the internet, we will find someone who has coded this component or who has found a way to work with it. And I can only recommend using that code. There's no reason other than maybe a learning experience to kind of push through and learn these very advanced components by heart. So when we have mastered that, understanding how to work with our components, the next step is functionality code. Again, this is not an academic term of any sort. It kind of just reflects my mindset of how to work with these things. Functionality is more about how does the Arduino actually behaves? How does it translate the idea that I had? How does it actually execute the functionality that I want? Not so much how it interacts with the components, but more how does it think? And this is very much related to algorithms. Algorithms is to some extent just a fancy word for a kind of a recipe to solve something. It could be, you could, if you really wanted, give your daughter an algorithm to how to bake a bread and call it that, but no one would likely understand you. It is just a recipe of how to go through certain steps to get a certain product. So that is kind of what we want to give the Arduino, and making these for some people is really hard, for others it is easier. There are some elements of talent to this, but it really comes down to, I would say, practice most of the time, understanding what is called algorithmic thinking. When you practice coding Arduino, you're gonna become better and better at understanding the limits or how your thoughts translate into code or translate into algorithms. Because one thing that's extremely important with algorithms is being specific. Humans in communication are not as specific because we understand the concept of context, we understand body language. So there's a lot of things that we don't need to say to each other. However, computers, they don't have this. So we need to be extremely specific, and the practice of understanding when to be specific and when we don't need to be specific really just comes down to doing it over and over again, or reading other people's examples. But this type of thinking can be practiced, even though that for some of you it might be harder than for some of your friends. There's also syntax. As we talked about earlier, there's the and, or, not, and not, all these types of logics that we can use. And just as with Arduino and as for many other programming languages, there are certain ways to write this. I'm going to allow you to, of course, have these slides and you can look through them. Else I recommend using Instructables or any other online platform like YouTube to just kind of learn these and work with them so that you understand the functionality of the code. I would say it's much more important to be able to read code and understand it than it is to be able to write code by heart. Because understanding the idea behind the code and how it is executed really just helps you so much more than being able to remember these things by heart when you're writing. So just before we move on, I would just say use all the tools that are out there and just really practice your basics in regards to how to think algorithmic thinking and how to create algorithms and understand them. And in this context, I just want to give some recommendations. There are, of course, the DIY process of doing everything yourself. This is a great learning experience. I would say it's to some extent much, much better than just working with forums and just copying a code from someone else, which you're not necessarily going to learn a lot from. That being said, it can be a very daunting task, and it's not for everyone to just sit and read through a lot of libraries and see how they actually work. We are lucky that in our day and time there have been developed large language model AIs that I have used to make my codes for Arduino projects, only having to do very minor adjustments myself. What I really like about these, and some people might consider them cheating, I think they're great because they can really translate specific algorithmic thinking into code, which is just super unique and super great as a learning experience in terms of what I've mentioned earlier. So, at least not from my perspective, I'm not gonna tell you to not use these types of tools because I think they're amazing and I think they're the future of a lot of coding. That being said, I do know a lot of software engineers, and as difficulty rises, these tools have to be used in very specific ways. They can or are not very good at solving very complex problems that humans are good at solving. But the most basic tasks, the most basic circuits are well within their reach. I just wanted to give an example of how an Arduino code can look. Then I will later try and upload it and see whether or not it works. First, what you see is me defining some variables. Variables is just giving a name to a certain value so that I can remember what it is, which is very, very good when communicating to others what these things mean. Then we see the void setup, which is the code that the Arduino runs just once. And as we might have seen in some of the earlier examples, there's the serial begin code. Serial begin is great. It is the communication between the computer and the processor of the Arduino or the CPU, or the microprocessor, sorry. Then there is the void loop. The void loop is the part of the code that will go on forever. It is the, you can say, the continuating thought or the continuating recipe that is going to keep on executing as time just progresses. Here we see in the code the Arduino reading the value of a sensor for this specific code. Let me see. It reads an analog value and then it checks whether or not this value that it has sensed is higher or lower of a threshold that you can decide. And then it does something. It says either digital write relay pin low or digital write relay pin high. So in this specific context, what I'm looking at here is actually a Arduino project, which is a water sensor and engine little circuit where You can, if you're very lazy, make it to have automatic plant watering at home. And the code here basically just checks, is there water in the plant? Yes or no? If yes, then I'm not going to water it. And if no, then I'm definitely going to water it. That's what this Arduino is seeing. So that was just a very short example of an Arduino code. And then we're going to continue into just a couple of more circuits in a second. And just before that, this was the circuit that I mentioned earlier with the code example was connected to this circuit. Very good. Hello guys, welcome back. Today we're going to talk about Arduino codes, how they are built, and the different functionalities of different types of code that you need to be looking for. I'm going to start out by going through one of the examples, just blink without delay. It's one of the simplest codes, but it will teach you quite a lot. So let's kind of just get into it. The first thing you see here is text in gray, which means that it's a comment. Comments refer to text that does not do anything other than give you information as a person. This will not be communicated to the computer, and the comment starts and ends with this, which is a dash, star, star, dash. This is a long comment in that regard. If you want to have shorter comments, like one-line comments, you do a double dash like this. And then again, you can see the text become gray. I can delete this, it's not gray, and then boom, it's gray again. For this specific example code, you can see first of all it says there is a circuit. First of all, you can use the onboard LED, or you can use the digital pin 13. That is a pin that is activated together with the inbuilt LED. And then you can also go to see the technical specs of the board, of the Arduino board, at the Arduino website. Who the creator was, the example code is in the public domain here in tutorials on the Arduino website, where you can also find a lot of examples if you want. Then we kind of head into defining variables. Those of you who have not done a lot of coding, variables are kind of a creation that is to some extent unnecessary for the computer, but is rather important for you. It basically helps us say, okay, the LED pin is this built-in pin, or an LED state is supposed to be low from the beginning. We could do other ways of doing this, but they are usable both in algorithms and in just increasing understanding. So saying that they're not important to computers is not really true, because we can use them in the algorithms, but most of them also we just use it to kind of give it a human name, or names that are easier to understand, or just to have it somewhere. So for example, let's see here the interval. We just say, oh, that's 1,000 milliseconds. That's how we want it to blink. We could just, instead of writing interval into the blinking function, we could just write 1,000. But it does increase our understanding of code, and being able to communicate this is super important. So it's definitely a good thing to use variables, kind of like create these things that we understand what is. And that happens in this state of the code. You can definitely also do it in other states of the code, and update variables, for example, later in the loop. But just when you kind of tell the computer that these exist, it needs to be able to understand that these different variables are there, whether or not they're there for us to be helped a little bit in our understanding, or if they're there to create some flow in an algorithm. This is the place where we do it. Second, we get the void setup part. The void setup is functions that are run once. So for example, the pin mode is a great thing to see here. Pin mode is kind of activating a pin on the Arduino, and what happens here is that we communicate to it the output pin, or we want the LED pin, which we defined here, which is the built-in pin, or pin 13. We want that to be looked as an output, meaning that the Arduino is going to push power into it, not expect power to come through it, which is the other option, which could be the input. So when it's done that, it is going to head into the loop part of the code. So loop part is what is run over and over and over. For this very simple code, it says also, again, it says here, this is where you put the code that needs to be running all the time. Then we have this is basically a reading of what is the time at this second, and then it kind of reads what is the current time minus the previous current time that we read. Is it less or is it equals to or more than the interval that we chose? If it is, this is what I call an if statement. So kind of if this is true, that the kind of difference between these two is larger or equals to the interval, we update the current mills. So the last time we said, okay, now we have activated. And if the LED state is low, we put it to high, and if it is high, we put it to low. So that is an if and else statement. Then we kind of write that to the actual LED in the Arduino. So digital write. The other option is digital read, which is one of the most basic functions in Arduino. And we kind of digitally, again, remember the analog and digital signals. Digital meaning we either deal with ones or zeros of 5 volts. But with digital write an LED state high, which means 5 volts, or low, which means nothing, to the LED. So let's try and just copy this code. I have already uploaded this to my Arduino. It's definitely blinking, but we can maybe just check how it would look in a Tinkercad environment. So this is a just slightly simpler version of the same code. Tinkercad, for some reason, does not really like this part of the long float, unsigned long here. So I have just used a float instead and defined it up here. Just making it able to run. You're going to realize these small things as you kind of learn Arduino and learn Tinkercad. Again, Tinkercad is free, it's online, it's not perfect, but it is pretty good. So let's see, start the simulation. All the code here in the loop is basically identical to what you just saw. So it adds in when it says like I like this code, and you can see here, boom, this small LED is lighting up. So if I'm not mistaken, we should be able to maybe also add an LED to the 13 one and see it working. We can just try, maybe I am wrong, which we can just jump into instead of code here, we just jump into component, whoa, not code. What I kind of just accidentally jumped into here is the circuit view, if you want it out as a professional circuit. However, again, for now, that is definitely unnecessary. But yeah, we grab a quick LED here, add a wire to it. This as well, boom, just get it over there. Normal, bam, bam, bam. This we need to hammer into a ground like this. And let's see if that works too. Yes, I thought so. Just like the code said, you can see that the LED here lights up and down. So that's basically all for this time. There's going to be a lot more work doing this, but I do hope that this quick example helps you a little bit.